All right, so what's a maximum? What's a minimum? I know there's lots of highlighted words here. I'll talk about them a little bit at a time. Maximums and minimums are referring to y values only. Please understand that. Write it down somewhere. Maximums and minimums are referring to y values only. If I ask you for the maximum of a graph, you're looking for the highest y value on the graph. If I'm asking for a minimum, it's the lowest y value on the graph. I hope you understand that, because some of you, if you ignore me, are going to write down x values. Now, I will show you a little bit more about that, but get that straight in your mind. Maximums and minimums are y values. Now, there is an additional, the maximum and minimum that you currently kind of envision in your mind has a little bit more information. We can call it the absolute maximum or the absolute minimum. And by throwing the word absolute in there, we are saying it is the highest or lowest y value on the entire graph. And then there's this other word. Okay, so absolute max, that's all, that's, stuff that you should be, y value, highest y value. Same thing with absolute min. But then they get into this word local. Local, or you could also call them relative. Local minimums, local maximums. That's a little bit different. Here's a graph of a fourth degree polynomial. Does this graph have an absolute minimum? Absolute minimum. It sure does. Okay. Maybe I should go back to the live version. What is the absolute minimum? What is the absolute minimum? Here, let me cut that picture out again for you. Absolute minimum. What are we thinking? If you're saying negative 6.25, you are correct. The absolute minimum of the graph is negative 6.25. Where does it occur at? The absolute minimum is negative 6.25. Where does it occur at? Now that question right there is now about the x values. Where does it occur? Negative 3.55 is one of the locations where it occurs at. Any others? 1.55. So after you write the @ sign, which we can use for abbreviations there. Okay, you're not going to put gmail.com, all right, as they were telling me in my second period class. Negative 3.55 and 1.55. Absolute max. What are you thinking? Okay. Yes, no. Right? Now, I know a lot of you are going to say infinity. A lot of you. Remember, we're looking for a number for the highest y value. There isn't a highest y value because it keeps going, okay? So don't use infinity, just put d-n-e would be fine, you know, it doesn't exist. That'll be fine, but, or none, you know, if you want to put none, or either one of those abbreviations would be fine, okay? But I know a lot of people like to say infinity, and so I just wanted to kind of warn you about that one. All right, now we need to talk about this relative. What does it mean by relative or local maxima? Okay. Can you create a small window, a small interval, and inside that interval, you get a lowest point, such as the window that I just created right there. Inside that window, in higher level math classes, they call it a neighborhood. I know. They get all Mr. Rogers on us. Mr. Who? Oh my goodness. Seriously. Oh.
My mom liked them.
This is painful. Our culture losing great heroes of our day. All right. I knew this day would come. People just forget. Okay. All right, assignment, YouTube, Mr. Rogers, okay? Fred Rogers. Let's get specific so we don't end up with something we don't want. Okay, I don't know what's out there, you know, they might end up getting, never mind. All right, so in this interval, do you have a lowest? So I'm going to use, let's say I say relative min. We could also use the term local. Not to be confused with loco. That is completely different. Okay, local or relative minimum. Inside that interval, is there one? This interval down here, do you see a lowest point? Sure you do. What is it? It's negative 6.25 at negative 3.55. Are there any others? Sure, there's no, you know, and. I guess we could put and, right? 1.55, because over here, there's another one right over there. Maybe I should switch colors, because it's kind of getting confusing. How about a relative max? We said there's no absolute max on this graph, right? But is there a neighborhood that you can see on this picture that has a maximum in it? Yes. The little hill, yes. Right there. Cute. Very cute. What is it? What is that relative max? 36 at negative 1. The y value is the relative max, and it occurs at negative 1. Okay, so that kind of gives you the idea of what absolute min, absolute max. You are not always guaranteed to have absolute mins and maxes. If I were you, I would find every relative or local min and max first, and then I would find my absolute ones second. There is a reason I suggest that order. The kids who find the absolute ones first, do you notice that these relative ones, I should say this, do you notice that the absolute ones also counted as relative ones? Well, most kids think that's not true. They get to the test or quiz and they think, oh, it's an absolute min. It can't also be a relative minimum. Well, sure it can, because it's in a little neighborhood down there and we can find a low value. So that's why it's important to understand that definition. Okay, grab your graphing calculator, get the equation graphed. Now, I'm going to be kind to you on the test. I'm going to be kind to you because I do not want you wasting time trying to figure out what the heck kind of window is going to give you a good-looking picture. All right? Oh, I better plug it in, otherwise it won't show on the screen. So probably have to close that up again. Come on, faster. Okay, there it is. I would use a window that looks something like this, -5 to +5 for the x's, and -30 to 10 for the y's. That would be my suggestion. -5 to 5 for the x's and -30 to 10 for the y's. Everybody have a cool picture like this? As long as you know how to do it, okay. Since you don't get that. I like this. I wish we could use this on every test. What? Are you asking me a question? Okay, any questions on how, I mean, that's the equation right there in case you didn't type that in, but it's also in your notes, printed or digital. Any questions on getting the picture? So we said we want to find the relative mins and maxes first. Okay, so it looks like we got two of those relative minimums, there and there. So we need to be able to find them. Okay, on your screen, go to Calculate, which is above the Trace button. Is there anything in this list which would help me find a relative minimum? Man, you guys need to work on not mumbling. Minimum. Yes, thank you very much. You never can tell if they're going to figure that out. Okay, it's asking me for a left boundary. I need to get on the left side of the one that I'm interested in. So I can either use the cursor and keep doing this, or if I know a value that's over on the other side, I can just type it, like -3. But if you want to use the cursor and just kind of keep going until you get to the other side, that's fine. Now it's asking me for a right bound, so I can either use my cursor or type a number in. The guess feature is only used if you have more than one minimum inside the range that you've given the calculator. If you only have one, you don't need to guess. You just hit enter. So, what do we have? We'll just go to the tenths place, just for ease. What's the relative minimum for that bottom one? -24.1 at, is it -2? 0.1? All right, that's good. All right. Go find the other one. What's the other relative min? Negative 1.8 at 1.6. Okay, how about the relative max? There's one right there. Find it for me. Find that relative max. Hold on a second. 1.3, yes. 1.3 at 0.4, 0.5. Yeah. Those rounding issues are not the biggest deal in the whole wide world to me. Tens, hundreds, thousands. Now, if you choose to round to the tens place, do it correctly. Or the hundreds or the thousands. That's I ask that you be accurate. Unless I specify a particular place to round, I'm pretty flexible on that one. Okay, we've got all that. How about absolute minimum? Negative 24.1 at negative 2.1. How about absolute max? All right, that's either the none or the DNE, right? Whichever you prefer. Because it doesn't stop, it just keeps going. So that's our discussion there in relative max, relative min. Okay. Jump back to this. Absolute min was the negative 24.1 that you had at the very beginning. That lowest value right there, that negative down there, that negative 24.1 at negative 2.1. So if you find the relative mins and relative maxes, then you're picking from those to get your absolute min and absolute max, unless there is none. Okay. All right, now. Some functions have a designation called even functions. They have the property that they are symmetric to the y-axis. Parabola is a very, very common one. Y equals x squared. But this definition that you see here is extremely important. We will be asking you to do a small proof on your test. And I do mean small. But you better understand this definition, which I'm going to walk you through, because most kids don't understand the definition. What do you notice about these two x values? Would you say that they are the same or opposite? They are opposite. What would you say about the y values? Would you say that they are the same or opposite? They are the same. Ooh, I wonder if I can do this. I probably will have to try. All right, I'm going to pause this for station identity. So opposite x's, same y's, as they move away in the opposite direction, they move in the same direction for the y's. Okay, that's what creates that shape and why we were doing that with our hands. Now, what happens when you are symmetric with respect to the x-axis? So, there's an example. They have the same x's and opposite y's, right? So if I was going to write that definition out, that would look like this. Same x's, opposite y's. What do you very much notice about this shape?
It's not a function.
It's not a function. It fails the vertical line test. Not a function. That's why we don't do a whole lot with these things, is because we study a lot of functions. But it's true. If you had the same x's and opposite y's, that would definitely not be a function. Well, what about this one? This one is an odd function. And its super cool definition looks like this. Yeah, we got opposite x's. And opposite y's. Hands back up. Opposite x's, opposite y's. So when you keep doing this kind of thing, guess what kind of shapes you're getting? You're getting things like this. The odd cubic function, right? That polynomial function that cuts through. How about the good old y equals x, right? That good old nice line with the slope of 1 goes through the origin. That fits. Opposite x's, opposite y's. How about your hyperbola that some of you can and cannot do? Right? You got your 1 and 3 quadrant with a positive k value, or your 2 and 4 with a negative k value. I know. Some of you are like, I can't do this. I understand. Okay? Pretty soon there's going to be some flossing involved or something. Okay? I don't know why our teeth need to be cleaned when we do that, but anyway. So, odd functions, flossing. Opposite x's, opposite y's. It doesn't mean they have to be in quadrants 1 and 3. They could be in quadrants 2 and 4, right? As long as they go in opposite. So what kind of symmetry are we dealing with here? Because this is not symmetric to the y-axis or the x-axis. I mean, we know it's not symmetric to the x-axis because it passes the vertical line test. But it's definitely not, you can't cut that thing in half with the y-axis and get the same looking picture on both sides. But what can we do? We can spin it. We can rotate it around what singular location and get the same looking picture. 0, 0, the origin. Now, how far should we rotate it? Do not be the kid who rotates it 360 degrees. Don't be that kid. Because they all look the same. Never mind. Okay, so you only spin it 180 degrees, right? You spin it 180 degrees. It has to look the same for it to have that kind of symmetry. All right? Trust me. Year after year after year, we spin it 300. Yep, looks the same. Must be an odd function. I'm like, oh. So rotating at 180 degrees. Now, when we get to the proof part, don't pull out your calculator, graph the doggone thing, and say, it has reflection symmetry across the y-axis, therefore it's an even function. That's not a proof. It's not an algebraic proof. Okay? It's nice evidence. The picture will help you, will help guide your proof. That's true. Okay? So what does the proof look like? You know what f of x looks like right there in letter A. They gave it to you. Step number 1. Tell me what the opposite means. What's the opposite of f of x? Please tell me. What's the opposite of that f of x? Somebody say e of x? No? Or what? Can you multiply this by -1? Anybody in the room? Yeah, what do you get? We will get a +3, that's true. And negative x squared. That is the opposite, folks. All right, now, here comes the proof. Okay. Wow, I can't spell. Proof starts with P and an R. Proof. Which would be step 2, by the way. This is what I need to figure out. What's this? What's f of -x? When you plug in the opposite x value, what happens? Okay, let's do some algebra here. -x squared minus 3. Folks, we're going back to the beginning function, and instead of plugging in an x, we're plugging in a -x. All right, so what do you get when you multiply a -x times -x? Positive x squared, don't you? Right? Those negatives end up canceling out. Okay, so here's my next question. Did you, oops, sorry, come on, stop that. Did you get the original? Or did you get the extra crispy? I mean opposite. Did you get the original or did you get the opposite? We got the original, didn't we? They match. Opposite x's produced the same y's. So this is an even function. Yeah, make sure when you're spelling the word function that you get the N. Whew, that was close. Even function. Opposite x's. I'm abbreviating here, just saying what's. Just for lack of room. It's amazing to me how many of you don't ever give me a reason. You just say, even. Oh my goodness. All right, so how about the next one? All right. So step number 1, what's the opposite of g of x? Hopefully you know that's going to be -x squared.
plus 2x plus 2. Okay, hopefully you know that. And then the actual proof, g of negative x. So I go back to the original, folks. I go back up here to the original. Everywhere where I see an x, I replace it with a negative x. Okay, so that's negative x times negative x. Okay, I bet everybody in the room knows this one. Negative 2 times negative x. How much is that? Right, that's 2x. And the minus 2 is just along for the ride here. So it looks like those negatives cancel out like we had before. We have x squared plus 2x minus 2. Did we get the original?
No.
No, we did not get the original. Did we get the opposite? No, we did not. If we did not get the original y value or the opposite y value, folks, we've got even, odd, and neither. What do you think it is? Oh, that's a neither. We didn't get the original. We didn't get the opposite. I wonder what the graph of the last one looks like. It's not a proof, folks, but go graph the last one and see if we can get an idea what it is. Y equals, I got x cubed. Let's do that fraction thing. X cubed. Alright, so x to the third over 4 minus x squared. And I'm going to start with the standard window. So zoom 6. Does it look like you can take the y-axis and cut it in half and fold it over and completely match it? Can you do that? Yes, no? No, because you'd end up having some branch over here like that that would match this one over here, and it doesn't. So it's not even. I can definitely tell you it's not even. Can you pick the whole thing up and rotate it around 180 degrees, take your whole calculator, rotate it around, see if it looks exactly the same as it did before? Does it?
Yeah.
So in your heart of hearts, you know right now that your proof better tell you it's an odd function. That's not proof, folks, but it is pretty doggone good evidence. So when you go through the steps of the proof, and yes, you probably need to practice. You need to go through that and understand what negative h of x looks like. That it's negative x cubed. Now, I will say this. If you change the top of that fraction and the bottom of that fraction, what just happened? If you multiply any fraction of the universe by the same number on top as you do on the bottom, what did you just multiply by? 1. And how life-changing is it to multiply by 1? Very? Not really. Okay? In fact, if you say multiply by 1 at a party, it better be the punchline to a joke. Just saying. So if you change, like you see in me, that I changed the sign on the top,
but I did not change anything in the bottom. Could you change the signs in the bottom but not the top? Is that the same thing as multiplying by -1? Yes, it is. You learned a long time ago that a negative could be in the bottom, or it could be in the top, or you could put the doggone thing out in front of it. But you can't do it to both, otherwise you've just eliminated what you thought you were doing. So let's see here. H of -x. What happens here? We've got -x raised to the third over 4 minus -x squared. All right, now what's interesting to me about this is that you have -x times -x times -x over 4 minus -x times -x. Now, I write it out in great detail like that for a reason. I'll show you what not to do, which I am afraid somebody would do. Because you have been trained and programmed that when you see a negative next to a negative, you cancel them out. Right? What comes before multiplication in the order of operations? Exponents and parentheses, right? Sorry, I lost part of my X. Okay. So you got to make sure you do this. Yeah, these two negatives are going to cancel out, right? And how many negatives are going to cancel out in the top? 2, right? And so you end up with -x cubed in the top, and you end up with 4 minus x squared in the bottom. Did we get the same as the original? Does this match the original? Yes or no? Definitely not. Does it match the opposite? Sure does. Which makes sense because you saw the picture, you turned it 180 degrees, you knew it was going to be an odd function. I am afraid that there will be some of you who will look at the calculator, decide it's an odd function, have no idea because you've practiced none of the algebra, have no idea how to show the proof. Don't talk. No, please no. I'm talking.
Specifically. Oh, he did a great job last Friday night.